Hi everyone, I am continuing to learn the Leo programming language. Today we are going to talk about functions. To begin with, I wanted to test the import tool, and it didn't work for me. Maybe I didn't quite get the documentation on the website right. I tried creating a folder in the project called imports and creating a full .leo file there. When importing into the main file, the program couldn't find the file to be imported. I tried solving this error. For example, I relocated the imports folder to the src folder. In the end, I never solved the problem. Maybe I'm making a silly mistake somewhere. Although the site says Leo imports are unstable and currently only provide minimal functionality, their syntax is expected to change. So I really made a stupid mistake. The name of the folder is imports. Then everything works. Let's move on to the next topic. Structs. A struct data type is declared as struct name. Structs contain component declaration name type. At this point, I don't know exactly what the uses for this type are. A record data type is declared as record name. Records contain component declarations name type. Record data structures must contain the owner and gates components as shown on screen. When passing a record as input to a program function, the nonce group component is also required. Each account record contains information that specifies the record owner, its stored value, and its application state. An Leo account can create a transaction to consume a record and produce a new record in its place. So this next one's a mapping. A mapping is declared as mapping, name, key type, value type. Mapping contain key-value pairs. Mappings are stored on chain. Function inputs and outputs. A function input is declared as visibility, name, type. Function inputs must be declared just after the function name declaration in parentheses. The transition function foo takes a single input a with type field and visibility public. A function output is calculated as return expression. Returning an output ends the execution of the function. The return type of the function declaration must match the type of the returned expression. He returns the addition of the public input a and the value 1 field. A helper function is declared as function name. Helper functions contain expressions and statements that can compute values. Helper functions that cannot be executed directly. Helper functions must be called by other functions. Inputs of helper functions cannot have visibility modifiers like transaction functions, since they are used only internally, not as part of a program's external interface. Increment and decrement. An increment statement has the form increment mapping key value. A decrement statement has the form decrement mapping key value. Increment and decrement statements can only be used in finalize functions. A finalize function is declared as finalize name. A finalize function must immediately follow a transaction function and must have the same name. It is associated with the transaction function and is executed on chain after the zero-knowledge proof of the execution of the associated transaction is verified. A finalize function finalizes a transaction function on chain. Upon success of the finalize function, the program logic is executed. Upon failure of the finalize function, the program logic is reverted. So let's go over the theory a little bit more in this video, and in the next video we are going to practice. Let's talk about operators. Operators in Leo compute a value based off of one or more expressions. Leo will try to detect arithmetic operation errors as soon as possible. If an integer overflow or division by zero can be identified at compile time, Leo will quickly tell the programmer. Otherwise, the error will be caught at proving time when transaction function inputs are processed. For example, to apply addition to a variable, there are several ways. You can see them on the screen. In the first line, we create a variable where we add 1 plus 1. Then we add 1 to 2. Then, using the add construction, we add another 1. Thus, the a variable has the value of 4. The same principle works for subtraction. All operators can be found on the Aleo website. That's all for today. If you like this video, please subscribe to the channel and like it. See you in the next video.